I'll do this recording. Oh, I should check. I have to upload the other two. I'll upload those today. They finished a while ago. Okay, back to optional. So where was I? Oh, right here. So the API is super simple. Basically, you can access the member by using either of these operators, the sort of just like a dereference operator, basically. If you ask a question in a Boolean context, or you just call has value, it'll tell you whether or not a value was set. And then you can grab the value by calling value. You can also do value or, which is interesting. Value or says, give me the value or some other default value. And you can do swaps and things like that if you want to. And then it has all the assignment operators and stuff like that. So its entire purpose is to, its entire purpose is to have this sort of nullable thing so that I can then say, const unsigned. Actually, I would just say auto. It's fine. Auto. I'm going to say result equals. So if I say square 5, then there we go. We're going to have our 5. You're complaining. Oh, you're not. Okay. We're going to say, result. Now this is going to fail. And then I'm going to go over here and say auto result 2 equals square -2. So now this is going to fail, and this is not really a gotcha, but this is one of the issues, of course, where it doesn't know how to see out an optional. So I can do this, and that'll do it. So now that's going to print out, and I can do it here as well. There we go, 24 and 4. Now, of course, I'm multiplying two negative numbers together. So this is, of course, going to be a terrible example, but we can do the same thing here. I can say if val is less than 0. Maybe I can't do negative numbers for some reason. I'll show you a more real example in a minute. There we go. That's better.
The standard optional override the dereference operator?
Yes.
Okay.
Yeah, that's what it's doing. So it's giving me 0. And 0 is interesting because it's kind of undefined. Like this is basically undefined behavior because it's reading some memory that I didn't write. So you have to be careful with this. So what I actually want is I want to say if result2 dot has value. I can also go here and say if result. That's also fine. I don't like this because this can make me think like, oh, this is an integer. And I'm going to see if this thing is anything other than 0. Like this is more explicit to me. So I pretty much exclusively do has value here. Just to be very clear, yeah, this is what this thing is. But now we can see that the 0 doesn't happen. That 0 is undefined behavior. That 0 is opening some, under the covers, it's probably a union or something similar. But basically, there's just a simple Boolean or something. So there's the value that you have, and then there's some Boolean that says whether or not it was set. Under the covers, that's kind of all it is. It's a really, really simple thing. So it's just a nullable type. That's all standard optional actually is. Yeah, read access violation, trying to read null. How so? How does it reduce this chance?
If your value is null, then having the has value check just passes by. You don't have to read from a null.
Here? No, because it overloads.
No, the second one.
what I'm saying is that it literally overloads operator bool, which means in any context that is a Boolean context, it's going to call this particular function.
I see.
So no, this doesn't do that. It reduces readability, but they're basically doing the same thing. Has Compiler Explorer always had like these weird motivational messages? That's interesting. I use it all over the place. Yeah, here's a good example. I'm getting some line intersection. This is some math thing in my math library. I'm getting a line segment intersection. Basically, this function takes two line segments and returns the point where they intersect. So that's a vector. So I'm returning a vector of whatever type I want, usually a float. But it's an optional. And the reason it's an optional is because it can fail. If the line segments don't intersect, then that's a failure. But what is a failed vector? Because a vector can be anything. So what's a failed vector? This is a good example of like a great use case for this, right? I could return a pointer, and I can new up a pointer and be like, here you go, but that's slow. And so this is a perfect example of a use case for standard optional. Hopefully this makes sense. And I'm sure there's others. This is line segment stuff more, still line segments. Weighted random takes in a weight type. I may or may not have a weight, a total weight. But that total weight could be 0. So like, what is that value? There's a bunch of things like this. I can get the playing offset, which is some double. This is for sound. But if there's no sound player, then I don't know what I basically return this failure. So like you can see these types of examples of like, here's a date and time. These are optionals because I may or may not have a start time. This is task creation context. I have no idea what this is. Task creation context. Oh, these are for AI tasks or really player tasks as well. So this tells me when I'm supposed to start and how long I'm choosing to do this task, which may or may not be a thing. So it's times, you have an integer and you're like, well, there's no real value for, a bad number here, for like an incorrect number. 0 can be used, but sometimes 0 is valid. -1 is sometimes used, but sometimes -1 is valid. Max int is sometimes used, but sometimes that's valid. So it's a good way to have that extra little bit. It does cost a little bit of memory and it costs a little bit of performance, but not really anything noticeable unless you're in some really deep inner loop. So that is standard optional. The other one we wanted to show was standard any. Now standard any is a weird one. I don't use it very often. I'm not sure that I've used it more than a couple of times. I don't think I'm even using it at all in my code. Whoops. I appear to not be. No matches. So standard any. It's a type way. As this thing says, it's a type safe way to create single values of anything that you can copy around. It stores an instance of the thing and basically allows you to like see if there's a value, try and give you the type ID of the value. You can do casts and things like that. So it's this sort of like magical thing. I generally don't use it because I like to have some more like explicit types, but it's one of those things where it's like it can sort of be anything. Now I want you to notice a couple things about this code. The first thing about this code is that it is not a template. Normally you'd have, standard any bracket, whatever, but it's not a template. It will deduce whatever it is. We can even run this code. I don't know if you guys knew that you can run code here. How cool is that? I can just type run this code and then here's the output, but I can literally just hit run. Here's the output down here. I can then change things. So I can go in here and I can say standard cout cat, and then I can run it again. And then here's my output with cat at the top. So I highly recommend when you're playing around with features, just experiment in here. Why not? This has just gotten better over time. If I hit exit from this, it goes away and it's back to what it originally was. So it's not like you're editing anything, and then our possible output is also the same. So standard any. So I'm gonna go back to this. So this is really interesting. Oh, it kept my cat. So this is gonna kind of show you what's going on. And I'm just gonna walk through this. I thought there was a reset at some point, but oh well. So the very first thing it does is it does this standard bool alpha. I think this allows us to print out Boolean values. Yes. Yeah, it prints out basically 1 and 0 Boolean alphas as true and false. So that's what's going to give us like this true, for instance. So that's what the line 6 does. Whenever you're analyzing code that you don't understand, don't skip anything. I mean, maybe in the very beginning do that, but you get to a point to where you should just not skip any of it. If you look at line 6 and you're like, no idea what this is doing, look it up, figure it out. Understand every single, like if we want to understand any, we need to understand all 45 lines of code. We need to understand why every single line is here. So let's walk through it. Line 1, this is, I'm actually gonna exit this. I don't get the line numbers now. All right, well then I will. Line 1, we have a header that we're gonna have to include. Line 2 is obvious. Line 3 is empty. Line 4 is our main function and our opening brace here. Line 6. Okay, so let's look at any. Line 9, we're creating an any named A and we're setting it to the value of 1. 1 is an integral literal. This is an int. Then we're gonna say standard type name. This is using the type ID stuff. I generally wouldn't recommend it except for debugging. I would never rely on this ever, but for debugging, it can be really useful because it just prints out the type. You can see it here. This type name gives us the name of the variable, basically. How cool is that? I think it only works in debug mode. In release, it might give you a mangled name. I'm not sure what it'll do. But this is a nice debug thing. So notice that now we have to do this standard anycast int a. We kind of have to do this because like any can store anything it wants. And one thing that you'll note is that it doesn't have any of those nice little like dereferencing operators. We don't have any way of dealing with it. So you have to do this anycast to kind of do anything. It does if we look up anycast, we'll note that what it's actually doing is returning whatever the type is based on whatever that operand is. And you can see a bunch of examples of that. So it's going to try and cast it to that type. It's a type safe thing. Now, notice if you look at this, where it's basically describing what it does, the one nice thing about any, and I'll do a quick example. Okay, that's already instantiated. So if I do standard any, I don't know, val, and I'll do what they did. I'll do basically val equals, I'll make it a string. It can be anything we want, so that should work. And if I do any cast into a const star, yeah, any cast const star val. So if I do this, and I'll just delete all this, then it should work. Yep, here's my cat, right? And so it prints correctly. Now let's break it. Let's convert it to an int. Oh, still prints cat. That doesn't make sense. There it goes. Sometimes the compiler, it doesn't catch up. Terminate called after throwing an instance of standard bad anycast. It threw an exception. That's what happened, which is not my favorite thing. We can catch our exception if we want to. We can do this so at least it doesn't crash. But oh, are you unhappy? No, there it goes. So I get exception bad anycast, right? This one, but the only difference that I'm catching it here. So it throws an exception. Now, this right here is why I don't really like using it as much, because it's very kind of exception heavy. I'm not happy. This says ill-formed. I kind of wish that this was more of a like, yeah, exception. If there's bad anycast, the type ID doesn't match. I kind of wish this was better. These are no accept versions based on pointers. Otherwise, so if you're using pointers, it will return null pointer and not throw anything. Interesting. Okay, so back to this. So we can just see what it's doing. This is basically how you use it. These are these anycasts. So you have to cast it back to the thing. And then you can see already they're doing a bad cast. So they're doing, here's the try catch. I wrote basically almost the exact same code, except they're being very explicit, whereas I'm catching any exception. Here they are int. Notice that they're setting a to the value of an integer, and they're doing a float cast. And it's still doing a bad cast. So like it won't even try. It's like truly type safe. And then it has value. It's going to do a check for a value. And this will print a value. It does a reset. Reset just clears the value. And then pointer to contain data. Here's them doing a pointer. Oh, that's interesting. You can pass it in the pointer of a thing. So that's interesting. So we can actually, I didn't know that one. We can get rid of this exception if we want to, because we can say, here, I'll do const int equal, result equals, so I'm just gonna pull this apart a little bit. So nothing here is gonna change except that I've assigned it to a value. So if I do this, I should get the same thing. There it goes. If I change this to a pointer and pass in the pointer of this, change this to p result. Now this is going to break, of course, but it lets me say if p result, then do that. I think this will just work. Yeah. Program returned 0. Yep. We're not, I can, to make this more explicit, I'll add an else. You know, not an int or whatever. So that'll be a little more explicit as to what's happening, because it'll say not an int. So that gives us a non sort of exception throwing way of handling this. I didn't know that one. That's good to know. You learn stuff all the time when you're dealing with programming. So that's standard any. It's kind of neat. It's, you know, I recommend against using it when you can, honestly. I recommend not using it. Just because it's kind of wonky. There are times, I know I've used this before. It's not in my engine, but I've used it once or twice. There are times where it's like, you just need something like this. You just need an any, because it has to morph, because that's the other powerful thing about it. And really, perhaps the most powerful thing about it is that I can now say val equals 3.14f. Right? I'm reusing the value of a different type. So now it's sort of faking this Standard any cast float val. Right. So the powerful thing is that it's a morphable type. That's what makes this super powerful. Look at that. That's what makes this incredible, is that it is, I can morph it into anything that I want, anything at all. And that's what makes this, that's what makes this that's sometimes you need this particular tool, right? Again, I generally think that there are other and better ways to do things. It seems worse than auto. Auto is different. They're not at all the same. This allows me, so auto is static. Auto is compile time. I can change the, change it and morphs into whatever it needs to be, but it only does it at compile time. Right? So if I do this and I say auto x equals 100, auto is an int. But if I then say x equals cat, that's going to be a compiler error. It's going to be like, it's an int, I can't assign it. Assigning to int from incompatible type const char star or const char 4. Right? So this is static. Any allows me to change the type at runtime. That's the power. That's what makes it powerful. And that's its entire purpose, is I can change type at runtime. That's how powerful it is. Now, there's other ways to do this. And I'm going to show you another one, which is standard variant. Variant also allows you to change type, but it does it differently, because you still have to show at compile time what there is. Okay, what time is it? I'm going to do variant. I'm going to show variant kind of quickly because I want to go and plow through a bunch of algorithms as well. Okay, so variant is like union. If you don't know what union is, then you're kind of in trouble there. But basically, a union is sort of a type where I might say, I don't know, whatever, foo. I name it and then I give it some values like int val, float val. And then I might do another one like, I'll do a Boolean. It's sort of the classic shitty union, but it's fine. What this actually does, so now here's sort of the powerful thing about this. Size of, I should print these out. So size of foo is size of foo. What do we think this is going to be? If you know how unions work, you'll know the answer. The size is going to be 4. The size of foo is 4. How's that possible? We have 4 bytes here, 4 bytes here, and 1 byte here. So what a union does is it says, give me enough memory to hold the largest of the values within my union, but only one of them is active. Right now, none of them are active. Actually, right now, nothing exists. So if I say foo, whatever right here, I've now declared this. I've allocated the 4 bytes that I need, but I've not done anything with it. So if I say foo.int val equals 10, now I've used that value, and I can actually now say foo, foo.int val, right? I've done it like this. And you can do all sorts of stuff. You can make anonymous unions and all sorts of things like that. And so there's a bunch of like ways to interact with this. So here's my int val, it's set to 10. There it is. I can make anonymous union. So an anonymous union would just be union. And then I might say, this is something I saw Aaron do and I was upset about it. Oh, he did it differently, I think. Well, I'll do it. I'll do a single one. Like he did something that was essentially like X and then like width. And you can technically do this. I'm going to do it differently though. I'm going to say int X float, you know, y. I'm just making shit up here. We'll see. This means that these are basically global variables in this context. So x is actually going to break. Oh, maybe I can't do it. Oh, it needs to be in a namespace. Anonymous unions at namespace are global. Must be declared static. Oh, I didn't know that. I've never done this. I only use them inside of classes because this just pollutes the namespace. But there you go. So now this is going to break because I'm going to delete this because I'm overwriting the name. So now I can say x equals 100, and I can say C out x, right? So I can do this kind of thing. So anonymous union just says skip the foo dot whatever, right? And lets me do this. There's x at 100. And this is useful for classes. So you can just say, oh, I'm using one of these three members. Anyway, there's different ways to do this. The problem though is, and I can set any of these that I want. So I can say foo dot float val equals 3.14f. I've now overwritten the memory for the float val, and I can even print that out if I want to. Float val, there we go. So, so now you see I have 10 followed by 3.14. Now here's the problem. All right, so I'm going to set this foo int, foo float. I'm going to do the int one again. Here's the problem. Let this compile, and there it is. I can read the data, but it's wonky because it's just reading the memory and interpreting it as an int. This is technically undefined behavior. This could crash or who knows. So we have undefined behavior here. You can't read values. So basically one of these three is active at any given time. There's no introspection in determining what is active. It's on you to just know it. You just have to know what's active. If we search my code base for union, you'll note that there's no unions. There's like a couple, I guess. Yeah, I'm using an internal event, could be a mouse move, a mouse wheel, or mouse click. And I have a constructor, which I think is a C++ 11 or 14 thing. I have a constructor that just sets the memory to null, essentially, it zeroes out the memory. And then I have that here, and that's about it. So I have a union here, and I know what type it is. In fact, you note that I very explicitly keep what type it is as an enum next to my thing. This actually could and should be refactored to be a variant. This is a really good example of what a variant would be better at. But I basically have an enum here that says, is it a mouse button, a mouse move, or a mouse wheel? And then I have my three events. Is it a mouse button, a mouse wheel, or a mouse click? I love how they're in different, this is in a different order than this enum is. So that's the mark of quality. You want these to be in a different order to allow the confusion of people to come in. And that's all sarcastic. This is actually not good. I wrote this a long time ago. You know, there's a lot that should be, so like really I should have the click event up here and then the move and then the wheel so that that's better. I'm just gonna make that change right now. But probably this should be a variant. So I set the type to some, you know, I force it in the constructor or whatever and all this other stuff, right? So this is the common pattern. So you can ask, and this is a struct, so I can just ask it, but you ask like, what's the type? And then based on that type, you can know which event you can do. This is super common. So variant just takes this pattern and makes it official. That's all variant does. It's basically this concept. It's this exact thing. Where else am I using variant or union? I consider to be the union. This is just me using union as set. I have it in one, I use it in one place in my code. So I don't use union that often. I don't even think we officially teach in any class. Maybe we teach it in 225. I don't know though. I don't remember because it's so rarely used. But let's talk about variant. So variant is powerful because it just makes all of that headache go away. So it does it a little weirdly, and you have to understand some fairly complex stuff, and it's C++ 17 specific. I've been bad about talking about this. It uses what's called a variadic template. So if you've never seen this before, this is it's basically it can have any number of template types. So that's what a variadic template is. So you can put any number of template types that you want there. And what it does is it creates a union essentially of those types. We'll look at the example here. In their example, they have int and float, and they have two of them. So right now what they've done is they've created two variables, v and w, and it's exactly as if I had my union with an int and a float. Those are my unions. They set v to 42. 42 now has the int part activated. And here's where they're getting it. So use standard get to grab it. Oops. They assert that 42 is equal to I, which it is. That, of course, is going to succeed. And then w here, they get the int of v, basically. And so this is just their example of like, hey, we can set the variance. These are all the same. Right, so they're just showing you could do some like basic assignment. Here they do this sort of annoying try catch where they try and get a float for w's. Remember, int is activated, so we're going to get an exception here. And then here they have their literals, so they're basically setting it to a variant with a string and so on. They're not showing the thing that I want. Which is get if. So there's a get and there's a get if. Get if is kind of neat because it returns a pointer to the value of a pointed to variant given the index or the type if unique, and returns null on error. So this is one way that you can basically say, does this thing exist? There's also this visit, which allows you to sort of provide the functor to the arguments and stuff for the variance. And there's other ways of doing this, but it's a way for us to basically say, does this thing exist, which is nice. Valueless by exception, yeah. So if I go to I might even just refactor this. Like I could just refactor this now and we could do it. So in order to do this, I would have to, wow, this is old. I would have to include EASTL variant, and it would just be variant in regular C++. So if I go down here, I would say, I would create a variant of these three types. So do this, oops. This, and this. These are my three variants. And then this would be event, basically. This isn't going to work. I'm not going to be able to do this like right out of the gate, but that's okay. I don't even need to create any of this memset stuff or anything like that. I basically just do this. And then this type happens. This is where I could like activate it or do whatever I wanted to. But I don't even really need this. I would just need to find out who fills this and who's using it. There we go. So all I'd actually need to do is I would need to say mouse event, and then I'd say mouse event dot type, no, event equals, and then I would just construct the thing, event. Go. I think I would have to do it. Oh, I'd have to do it like this. I'd have to say EASTL get. I would have to say this is going to be, this is SFML mouse. This is the wheel event. I'd have to do something like this. Get equals this whole thing. Something like that. This isn't working because it doesn't know what EASTL get is. So, oh, IO stream. That's fun. Oh, because it's C air. So this would again be EASTL. Just include variants, really fine. And so that should fix this guy. What do you not know? Oh, it doesn't know what SFML mouse wheel event is. Interesting. I feel like it should know what that is because I'm literally using it here. Huh. SML input events. Yeah, it's right here. It should know exactly what that is. Well, whatever. The basic idea is yeah, I don't know why it wouldn't know what this is. SFML input events. They're literally right here. I wonder if I have some weird circular issue. No default constructor exists. Well, that's easy enough to solve. The idea is that it should be able to just kill all of this and this and this and even this. I should be able to kill all of this. Are you better now? No, it's unhappy. I don't know why it thinks this is undefined. Oh, there's two of them. Oh, namespace. There we go. And then this would be, I probably do this. Nope. SFML wheel. Yeah, this should be right, I think. I thought I just need to do this. So it doesn't know what any of these are. I probably need to do it for reals then. No, it's a struct. I should be able to do wheel type, delta, all that stuff. Okay. So wheel type, delta, mpos, really wish they had the named parameter types in. So that should be better. Nope, it doesn't like it. This is a constructor. That's what I don't understand. This constructor should call because of this. That means I probably have to create a stupid constructor for this. Well, this is maybe a more complicated example than what I actually wanted, because it means I have to do this kind of stupid thing. So I have to do SF, mouse, wheel, you know, whatever, wheel type, and all this stuff. But I think you get the basic idea of what's going on here. This is just going to do these things. They should, I wish there was a better way to do these kind of pass-through constructors. I thought I could do it. Oops. I think I can't because I have the default constructor in there. There we go. That took a long time. So now this is basically, it gets replaced with this. And I can actually replace this even more, because now if I go here to these input events, I don't know why I even have this class. Now I can say using SFML mouse event equals just a variant. It's literally just this. This goes away entirely. So it gives me a little bit of a, whoops, what do I call it? SFML mouse event equals that. Yeah, that's right. Okay. Like now I can just do this. And so now SFML mouse event is literally just the variant. And now I don't even need like some of this stuff in here, because this is just now mouse event. So like it simplifies some of that code. This code is still kind of a wonky thing, but it basically simplifies like a bunch of that code, which is nice. And this is all in one little system that I can just make it work. And I would do the same for each of these. I would do it for the button press, release. These are both mouse events. I do it for this thing as well. And I could literally take this whole thing. I wonder if I can actually just do know what it is, but that probably doesn't matter. Now I'm getting a little crazy on this. I think equals, I think I can do this. There we go. That's even better. Look at that. Now I don't need that stupid ESTL get. Now the cool thing is I can just do this. I can copy this pattern basically everywhere. And I can say, okay, you are a mouse wheel. So you are a mouse click event. And of course, I need to change all this stuff. So button and all this kind of crap has to change. So this is going to be event dot, whatever all this is. I don't think I can just grab all this. Let's do it like this. You guys know you can highlight multiple things like this, right? This is super powerful. Oh, wrong one. Like I can just sort of grab this, hold down Alt, and now I'm just highlighting this in a big box, copy, and go in here. That. What's that? There we go. So we have event dot, whatever these things are. And those go away. Right, and we can keep going through this, and it's not going to work this exact way, right? Because I have to do event dot button. So I'm actually screwing this up. Anyway, hopefully that makes sense. Working in other languages too long. Go. There we go. Something like this. And then this isn't going to work because, of course, I have to go in here and change the click event to have its own thing. So, you know, I'm not going to sit here and keep doing this, but I think that makes some amount of sense to you guys. Let me know if it doesn't, and I can keep going, but that's the basic idea, right? And that's a little mini refactor for how this kind of should work. Okay, last one. Let's see, pause, and then why are you unhappy? What am I missing? SF mouse button. Button is an enum. I don't know what I'm missing here. Somebody probably will call it out soon. All right, what's the actual error? Expected a close parenthesis. There we go. And so now this should work. There it is. So I'd have to do the same thing. Oh, and these go away. So I'd have to do the same thing here. This is going to be a little different. This is exactly the same code. In fact, I can do this right now because this is the same code, except that this is set to false. And then I would do one more here for mouse moved. And then it should just work at that point. There should, although I might have other places where I'm accessing it that I have to care about, but that's the basic idea. Okay, that's it for those things. We've got half an hour. So I want to go through some of the different like algorithms and stuff. So hopefully that was useful. Let's go back to C++. So I want to talk about the algorithms and the numerics library, maybe type traits, but I'm probably not going to have time to do that. So let's look at algorithms and look at numerics. Algorithms and numerics are two very powerful libraries where they throw a lot of really interesting stuff. And I'm going to open my window, but I'm still here. The numerics library is really about like kind of mathematical type stuff that's not quite mathematical, like numeric type things. And the algorithms library is like classic algorithms. So if we look at the algorithms library, here it is. This is all the things in it, and it's pretty big. There's a lot of stuff here, and we're going to slam through it and talk about some of it. The numerics library has other bits as well, but it's like numeric based stuff. So we'll look at a few of these as well. So I'm going to start with numerics because it's smaller. There's a bunch of constants and fun things like that in here, which I'm going to mostly ignore. I would just go through this. Honestly, I would go to the numerics library and just scan through it and see what's here. C++20 added midpoint and lerp. Lerp is pretty cool, linear interpolation. But in terms of like things that we can do, accumulate is a very powerful function. What it does is it accumulates values. And you like a lot of languages have a sum. And so that's a good example of something that it can do. And that's actually the default. So if we look at an example of that, and I'm going to kill all of this stuff. I'm going to include algorithm, and I'm going to include numeric. And I'm going to kill all this crap. This. So I'm also going to include vector. So if we have a vector of integers, which we set some reasonable thing, if we say accumulate val.begin, val.end, we need an init, I think is the next thing. I always have to look this one up. Where is accumulate? There it is. Init, yeah, that's the other one. Init, and we'll set it to 0. Auto result equals this thing. And we can print out result. There you go. And there it is. Result is 30, which is right. 10, 20, 30. So this summed up is 30. So that's a summation. And it lets you do that with anything. And I can initialize, this initialization lets me do it to anything. I don't think I can do this. Compiling, nope, I can't. It needs an init, which seems silly to me. But it needs one. Init is almost always going to be 0 anyway. But that's not all it can do. You can do any binary operation that you want. It's molt or something like that. That's definitely not it. All right, crap. This will tell me. I thought they had a bunch of multiplies. Nope. Wait, really? Oh, it has to call it. Or instantiate it, really. There we go. The result is 0. Because it starts at 0. So I should probably start it at 1. And there it is, 3,840. That's the product of all of these values multiplied together. You can actually do anything that you want in here by just passing in a lambda. And it takes in 2 parameters. It takes in left and right, or whatever those types are. They could be floats or whatever you want. And so in here, what you do, it's not left and right, is it? It's actually the current accumulation and the value we're looking at. That's right, because I'm summing it all up. So it's going to be current and value or something. And so if I just want to do a summation, current plus, I just return current plus value in my lambda. I want to set this to 0 and I should get my 20 again. 31, but it's going to change to 30 in a second. There it is, 30. Right? So I can put anything I want in here. And because it's a lambda, I can capture things. I can do all sorts of crazy stuff. You know, I can square each of these and, you know, I can do it like I can do anything that I want here. So I could say current plus equals value times value. So this is, you know, here's the sum of the squares, right? That's the power. That's the powerful nature of this, is I can do anything I want. Sum of the squares is 220. So starting with 0, of course, here. So hopefully that makes sense, and what this does. So accumulate is a really good way of doing summations, products, whatever you want. And it's a powerful way to not have to write that for loop that we've all written a million times of, you know, int whatever equals 0, you know, all that kind of crap. So accumulate is really powerful. Now there's a bunch of similar things in here. By the way, this kind of programming is a newish thing to C++ 11 that we generally call inside-out programming, or inside-out programming is mostly what I've seen it written as. The idea of inside-out programming is like your typical programming. You write, you know, you might write a for loop that calls a function, right? So you write an algorithm that calls the work. In inside-out programming, you call a function that is the algorithm, and then you provide it a lambda that is the work, right? Because the other way to do this is some, you know, inside-out function or something, or some right side in function where we would do for, you know, auto int, or not int, auto x in val, and you have some like int result equals 0. This is our initialization, and then you'd say you know, process or whatever you want, and you pass in, maybe you pass in both result and x. You know, like this is sort of the more traditional way of doing it. So that's why they call it inside out programming, because here the function is the work, here the work is the thing that's right in front of you. And it can be better and it can be worse depending on what you're trying to do. This can be more expressive depending, because you're also seeing the algorithm right here. I like these kinds of functions mostly because to me, it's not hiding anything. Like you could write this accumulate, there's nothing magical going on there, but it lets me easily focus on like the thing that I actually care about. It can also be faster depending. Okay, so that's accumulate. Now, if we go back to the numerics library, there's also a concept called transform and similar things like this. Reduce is similar to accumulate, except out of order. So reduce is kind of its own sort of weird thing, but it does it out of order. So it's a little different. So for our summation, this actually would work because the order doesn't actually matter, but at times the order does matter, then it can matter. And the reason why this is different is because it has these policies. I'm not going to get too deep into execution policies. I talk about them in GAP 295, but the basic idea is that in some algorithms, you can pass it a sort of like parallelism policy, or execution policy as they call it, which says, oh, this is something that you can throw on multiple threads. And so if you have a massive thing that you're trying to accumulate, then you can gain performance. I have yet to actually gain performance through this. So I've tried it, every time it makes it slower. And I don't know if that was because I was trying it like back in the C++, I think 14 days or whenever they first started it, maybe right when 17 became a thing. So there's a bunch of things in here, and these are all just mathematical concepts. So I'm not going to go through all of these, but like there's rotations and bit shifting and all sorts of stuff here. So, oh, endian. Interesting. Indicates the endianness of scalar types. That's new, C++ 20. So I would look through this stuff. I just want to show you an example of how accumulate works and how just generally these things work. algorithms works more or less the same way. These are all kind of these inside out functions. So I'm going to skip ranges because I have another talk that I'm doing on C++20, which does go through ranges. I'm going to talk about for each because it's sort of hilarious. It's literally a for loop. It's this loop. Or I deleted it, but it's this loop. This is a for each. I see almost no use for it, but some people like it because it does have an execution policy and you can do stuff like that. I basically never use it. I use it on very rare occasions, I guess. But these all of, any of, and none of are interesting algorithms. All of, any of, and none of they all return Booleans. They loop through whatever it is that you're trying to loop through. And all of says, you pass it a value. I think you can do either. Oh, maybe they're always predicates. Yeah, they're always predicates. You pass it a functor, you pass it a lambda or whatever you want. Here's an example. Or actually that's an implementation. Here's an example. So this is going to say all of, this basically says, so you give it a lambda for which things return true. So here's an example of all numbers being even. So this is the actual lambda that they've passed in, which just says, it takes as a parameter the value and it says, this is how you check for something is even. This will be true if even, false if not. And so it basically loops through everything and says, is this thing true? Is this lambda true? If it is, great. If it's not, it early outs and says, nope. So all of says everything has to be, none of says none of it has to be. Ooh, standard bind, that's a faux pas. None of says, none of them are odd, basically. So this will also succeed. This is a terrible, they shouldn't even have this here. Standard bind is basically deprecated at this point. You should never use it. You should use a lambda instead. Look how much more expressible and readable this is. They have divisible by, which is interesting. Here's just another example. And any of says any of these things match this criteria. How many times have you looped through something to see if something exists, right? So that's where these any of, none of, all of come into play. You can still write the loop if you really want to. These are just convenience ways of doing it. And as said before, they have execution policies. So you can create a policy and say, I need to know if anything here solves this thing. It returns true basically if any of these things happen. Excuse me. And I'm going to pass in, I'm going to let a bunch of threads spin up and handle it for me. And so it's ways to do that kind of stuff. It's ways to handle that. Also, you'll note that they're const expr, which means this will run in constant time. It'll run at compile time if you have a const expr thing. Let's look. So am I actually generating a real assembly here? I guess so. For example, I have my integer here. If I say bool, I'll do the even one, is even equals standard all of val.begin, val.end, and then I'll do basically what they did. Val, I'm not going to use val, that might be confusing. I'll use x. Return x 2 is equal to 0. There we go. And then we have is even, and then I'm going to say standard cout standard, what was it? Alpha bool, that thing that I just learned. That definitely isn't it. Is it bool alpha? I don't remember. It doesn't matter. It's gonna be 1 or 0, and so I don't care. Is even. And so here we go. This should be true, or 1. There it is, 1. If we look at the actual code, XOR EAX. It's just, yeah, it's too smart. So it's not even calling it because it realizes that this never changes. And I don't have an easy way to make that a thing. But it doesn't matter. It's just, it's outsmarting my attempt to do it because it's literally just passing in one, it's not even calling my function. But the idea is the same. You can kind of see what's going on here. By the way, when I write these inside out functions, I like to write them like this. Because to me, it just feels more readable, where it's like, okay, this is the thing that I care about. This is the algorithm, and then this is sort of the bot. Like I treat it like a loop, where like this is the loop, and then this is the body of it. So I often write lambdas like this. You're welcome to do whatever you want as long as it's readable. This is relatively readable, and in this instance, I actually probably would do it like this. Okay. We got a few more minutes, so I'm going to go through some of these. Count is another one. So count if you pass it a lambda and say, count the number of times this returns true. Mismatch finds the first position where two ranges differ. Interesting. So this will go through two different ranges that you give it, and it will find the point where they stop being true. That's interesting. String has some functions that are like that. Find just finds an element given whatever criteria you want. Find finds the value. Find if you pass it a lambda, and then the lambda, you can do anything you want on that, which is really cool. Find end returns the last sequence of elements within a certain range. So you can find first and find last and all that kind of stuff. Adjacent says finds the first two adjacent items that are equal. So there's some fun things in there. Search will search for a range of elements. So find finds a single element. Search finds a range of elements, like for a range of elements. So you're finding the pattern, 2, 3, 4 or something like that. There's search, which search n, which search only a certain number of elements. You can copy things. You can copy certain like ranges of things and say, okay, only copy these number of elements. Copy if is really interesting because it's copies only if a lambda that you pass in is true. So you can have a sequence and say only copy the even values from this sequence. So that's really powerful. In general, if you're using C++, 20 ranges are going to be better for almost all of this stuff because they're only evaluated when they're actually needed. Anyway, copy backwards, you can sort of reverse things that way. There is a reverse, I think. Move moves a range of elements to a new location. Move backwards. There's fill. Fill is really nice because I can say standard vector. I can give it an array, right? I can say int, whatever, array 128. I want 128 integers, but I don't really want to deal with initializing them. So I can do standard fill. Begin, what I call it, array, standard end, array 0. Now I filled them all with 0. I filled this array. Full disclosure, though, I wouldn't actually do this. I would do a memset because that's probably faster. Although I think fill will drop to a memset under the covers. I think it's actually going to do the exact same thing. But here I am filling it with 0, but you can fill it with anything you want. And you can use, non-integral types or anything that you want here. So that's where fill gets really powerful. Fill, I think, also has no, it's always value. But it does have execution policies, which is nice. Transform, that's the one. Transform, generate is actually what I was thinking of. Transform applies a function to the range of elements, storing its results in a destination range. So that's pretty powerful. Basically, it loops through an array, calls some function, and takes your function that you pass in, and takes the results of that and puts it in some other array. This is really powerful. I use this one quite a bit. Here's an example. I create some string called hello, transform s.begin, s.end, s.begin. So this is interesting. They're overwriting their own array, which is valid, apparently. So not all algorithms let you do that. The lambda they're passing in returns an unsigned character. That's a choice. So what do I unsigned? And returns to upper. So it just calls, it basically is going to take hello and make it all uppercase. That's all it does. Now we're creating a vector of size t's called ordinals. We do this back inserter, sort of a wonky thing that says just insert to the back of this array or the back of this vector. And this returns c as a standard size, as the size t. So it's just a conversion. So it's giving you the size t values of those. We're going to loop through that and print them out. So here they are. These are basically the ASCII values. Well, this is. It's going to do another transform. It's going to add standard plus, I assume, add something to them. I don't actually know what this does. Standard plus. Function performing addition effectively calls operator plus on 2 instances of type. That's what okay, so it requires 2 things. So this will just sort of add them together as it passes in the various values, and here they are, and so on. So it's pretty straightforward, I think. It's a transformation. Remember my famous saying, right? What is programming? Programming is the transformation of data. Well, now you have a function that transforms data. That's all it does. Generate is interesting. It assigns the results of successive function calls to every element in a range. So generate is really cool because that's how I could do a fill by using a lambda. So with a lambda, I can pass in whatever I want. For example, if I wanted to fill up this array with a bunch of power of 2 stuff, you know, I could set something like that up. So instead I would do something like standard generate standard begin array. Standard begin and standard end are free functions that work on like C types as well. I don't think it takes anything in. 0. Does this work? Yes, this works. Compile. Come on, there we go. Okay, so that's what I wanted. Okay, so what I can do here is I can say something like index equals 0. Is this what I want? I think this is what I think I want 1. Index equals 1, and I'm going to make this mutable. And so then what I'm going to do is I'm going to say, oh no, I have to return it. So I think I want actually index equals 0. And so I want index shift left. And I'm going to make this way smaller. I'm going to make this like 8. Index shift left equals 1. That's not going to work. Yeah, I do have to do this. Okay. So I'm going to say const result equals index. Index is maybe the wrong term here, but it's fine. Index shift left equals 1. Return result. There we go. What are you unhappy about? Okay, there, it's good. And so now I'll do a standard for each, because why not? Even though it's annoying to type, and probably I actually shouldn't do this because I don't really like standard for each. I feel this is less readable, but I'm going to show you just to show you how it works. Int val. Show you standard for each, why not? And come on, buddy. There it goes. 1, 2, 4, 8, 16, 32, 24, 128. So I've just initialized this to a nice, fancy power of 2. Like I've just initialized this array to power of 2. And all I have to do is change this to 16. And now it's way bigger. Or not. There it goes. And there they all are. So I'm just raising it by power of 2 every time. right? So that's the power of things like generate. So like, see how powerful these things can be. It lets you ignore any of the constructs of this and just concentrate on like, what is the algorithm trying to write? This also demonstrates the really powerful thing of, remember, lambdas are just classes. They're not anything magic. They're just classes under the covers. The classes are sometimes, as an optimization, a C-style function pointer. So I can create a member variable that serves no other purpose than to have a member variable. And I've made it mutable so I can edit it. So that's all I'm doing here. I've created this little thing. I don't need some external thing. This is super, this concept right here of lambdas, I feel like I could do an entire one of these talks just on lambdas because they're so expressive. Look how expressive this is. And just what I've done here, like it's all easy. Because in old school C++, I'd be like, okay, struct, you know, whatever my lambda is, and I'd create some stupid, like I'd have to go through all this crap, right? Like, and I'd have to come up with some name for it. It'd be like, I guess it's some like power of 2 generator, and I have to do this like int index, and then I do public, and I'd create like power of 2 generator, you know, index starts at 1. And then I do, you know, what? I guess it would be int operator function call, which takes in no parameters, non-const. So then I do this body here. Like I do this sort of, like I have, look at how much code this is. Look at that. Look how much code that is. That's like what, 13 lines of code? And then I could add this thing in here. This is why nobody used algorithms in C++ prior to 11, like you wrote your own. And here I express the exact same thing with what, 3 lines of code, 4 lines of code? Look how powerful lambdas can be. Because what I'd really do here is this whole thing would go away. And I do something like this. And I have this code in my own code base just from before C++ 11. And I do like power of 2 generator. Like it would look like, I think this works. No? Yeah, there it goes. Like this does the same thing, but then like if you're looking at code, you're like, okay, standard generate begin and power of 2 generator. Okay, let me hit, oops, that was the wrong button. Let me hit F12 and go like figure out where this is defined and understand what this is. Whereas here, it's right here. So I don't know. I think that just to give you a little idea of how powerful it is. Okay, we're over time. I'm going to blast through sort of the rest of these and just talk about them. Remove or remove elements satisfying criteria. So you can just remove a bunch of stuff. You can do a remove and copy. You can replace a bunch of elements. You can swap elements or swap whatever you want. You can swap ranges of things. Iter swap. Iter swap is just like swap ranges. It's just swapping, but using iterators instead. You can reverse a container. You can reverse, but create a copy of the reversed container instead of just reversing in place. You can rotate, which will rotate elements around. So if you rotate something off the end, it'll put it back in the beginning. So that's pretty cool. You can shift containers, so it'll just null them out as you go forth. Shuffle is like if you have a deck of cards or something, you can shuffle them. It's in here. Oh, ranges shuffle. Oh, I guess random shuffle. I don't use shuffle. I have my own algorithm. It's the same algorithm. It's the, you know, Fisher-Yates algorithm or whatever, but they force you to use standard random, which I don't like. Sample will select n random elements from sequence. So these are like random things. Unique will remove consecutive duplicate elements. So if there's 2 elements that are the same right next to each other, it'll remove them. So a common thing that you might do if you have a big list that you want to deal with duplicates and you want to remove all the duplicates is you sort the list and then call this unique function, which is just n. So that'd be like, what, 2n times log n or something like that. So slow, but less bad than doing the crazy n squared method. Is partition, and these are more like partitioning operations. Partition is used in, you see it mostly in things like sorting. So like quicksort, for example, does a big partition. So it puts a partition in the middle, not in the middle, but at some point. is sorted, literally loops through the array and sees if it's sorted. Is sorted until, oh, that's interesting. Finds the largest sorted subrange. You can actually sort something. You can do partial sorts of things. There's a stable sort. Nth element says, give me the nth element. So you can have an unsorted array and say, I want the third largest element. That's what this does. We actually look at this in data structures and algorithms, and I will implement it if we have time. This is a really interesting algorithm. Lower bounds, upper bounds, equal range, things like binary search. We'll look at this in data structures and algorithms as well. Binary search takes a sorted range and does a very quick search through it because you can cut the problem in half every time. Merge has two sorted ranges and merges those sorted ranges together. Includes, returns true if one sequence, includes, so if a subsequence is within a sequence, it will return true. I haven't used a lot of these. If you have sets, you can have intersection and union, and so set operations, there's unions and differences and intersections, all that stuff. You learn that more in data structures and algorithms for those who aren't there yet. For those who are there, we talked about it in the first day. Here's how you can do it with data structures. We talk about heaps in data structures and algorithms. This is all the heap functions. Minimum and maximum operations. So you have max element, min element. The only difference between min and min element is some stupid libraries like Windows define macros. And so if you need to care about that, then min element and max element are just ways to deal with it. So min max gives you the smallest and largest of various elements. Clamps is really useful because it lets you clamp. You can say, pass it any value and give it 2 clamp ranges, and it will force the value to be within that clamped range. Equal in terms of 2 sets. Oh, these are comparison operators. So these lets you do various comparisons. Is permutation. In terms of a sequence is a permutation of another sequence. So there's lots of things like this. Inner product, here's accumulate. Oh, we have numeric. I guess it includes all the numeric stuff. So here's accumulate, adjacent differences, and so on, partial sums, transforms, and other such things. These are more the numeric stuff that we looked at. Ooh, destroying ranges of objects, and so on. Then there's C library stuff like B search and Q sort, which I wouldn't use anymore. We have better alternatives. So it's vast. There's a lot of stuff here. It's worth flipping through this and just seeing kind of what's here. We kind of went through it, but it's worth going through it. I go through this every now and then and just see what's here. I mean, I am surprised about the things that actually exist in this, in this world, and especially as new library features come out. There's some really powerful stuff in these things. C++ gives you a huge number of libraries that you don't have to implement yourself. I don't know that I would use them outright. I don't know if I would say just use the standard library all the time everywhere, but I would say evaluate if this is what you want. And at your point in learning, the answer is it probably is. Unless you're more advanced, unless you look at that statement and say, well, I disagree with that. If you can tell me that you disagree with what I just said, then you're probably advanced enough that you're welcome to use other libraries. I mean, I disagree with my statement that you should use, C libraries for C++ libraries for everything. But when you start getting more advanced, you'll start saying, oh, maybe I want to use EASTL for containers and algorithms, or like me personally, and what I generally push for the later, more advanced students is maybe I want to write my own random number generator. You can write a random number generator in 6 lines of code. And you can a really, really good, super high quality random number generator. I'll even give it to you. Random number generator. Let's see. I need to go to the engines, which is XOR Chef 128. Here it is. Literally 1, 2, 3, 4, 5, 6. Literally 6 lines of code. That's a very powerful, amazing random number generator. It's not the best in the world, but it's really fast and it generates really good random numbers. And that's what we care about for games. We're not trying to model the, heat decay of the universe, or solve, how cancer cells propagate. We're trying to determine if there's a sword in a fucking barrel. We don't care. So it just needs to be decent. And this is a really decent random number generator. I would love to tell you that I wrote this incredibly good random number generator, but I didn't. It's called XOR Shift 128 Plus. Here it is on the wiki. And these are all varying. Oh, this is Zora Shira. This is not what I want. XOR Shift, here it is. I mean, that's also a good one. XOR Shift Plus. The plus variants, I think, are the better ones. Yeah, here it is. XOR Shift 128p. This is it. Looks like it's slightly more complex in their version, but I basically copied and pasted this. And you should too. This is a really powerful. I wouldn't do it exactly like this. This is a C implementation. One of the big changes that I made, which is very common in games, is I turned it into a class so I can instance it. This is the engine, which is instance in my random number generator class as a template type, and here it is. So this allows me to have the same interface, but switch between different engines. The two that I have implemented in my game engine are this XOR Shift 128. It's XOR Shift 128 Plus specifically. The Plus variant is the better one. And I have a Mersenne twister in here, which I used to use. That used to be my core one. I spent all this time making it so I could switch between them. And I guess how many times I switched between them. If your guess was anything other than 0, then you're wrong. I never switch between them. Why would I? I don't care. But I might at some point or something, like, I don't know. It felt right to allow me to switch between different engines. And it also means it's trivial for me if I want to try out another random number generator. And that was actually the real reason, because I might change XOR Shift 128 Plus to something else. There are further iterations of that same core algorithm that are supposedly better. And it's changing a random number generator is a huge deal. Ultima was famous for using the same random number generator for something like 7 versions. Like Ultima 1, which was like Commodore 64, all the way up to Ultima 7, I think, which was PC. And then I think in Ultima 8, they finally rewrote the random number generator. And that was written by Lord British himself, Richard Garriott. And he won the award at Origin Systems for having the longest living code in the Ultima code base, because he wrote the original random number generator. And I think you can find it somewhere. And it's written in assembly language, because that's what it was back then. That was, the 80s or 70s or whatever. I think Ultima 1 was what, early 80s? Yeah, 81. I was barely alive. Yeah, Ultima 1 was 1981 on the Apple II. I was wrong. Yep. A good friend of mine got his start at Origin Systems working on Ultima 7. And so that's how I know some of the history of Ultima. Okay. So consider the things to use. The high-level libraries, this is what I'll end with. The high-level libraries are, which I started to do but didn't go fully into. There's language support libraries, which include things like coroutines, numeric limits, which are like max int, stuff like that, initializer lists. Three-way comparison is a wonky thing. It's weird, and I get why it's there, but it's still weird. The type support, so like type traits, like, is this thing destructible, all that stuff. You'll get that as you go further on. There's the concepts library, which is new to C++ 20 and will fundamentally change how we interact with templates. There's the diagnostics library, which is debug introspection. There's generic utilities, so we have smart pointers, we have date and time, so standard chrono, that kind of stuff. Function objects and hashing and stuff like that. So functors that the language provides, so like that standard multiplies that you saw was part of this library. There's string conversion, so that's like to string, the standard to string stuff. Utility functions like standard pair, tuple, optional, any, format, and variant. Format is a way to format strings in a more sort of easier way.
than doing a bunch of pluses and stuff. Tuple is a sort of like standard pair, but you can have as many as you want instead of just two. And it's mostly unreadable. I generally recommend against it. There are better ways to accomplish the same thing. There's strings, so all the string stuff. There's containers, so array, vector, deck, map, unordered map, set, unordered set, priority queue, and span. I would also generally include the heap functions in here too. There's other containers sequence. Oh yeah, the so like, oh, I think sequence is one of them, but there's like the string view and stuff like that. Sequence, if I remember right, is basically string view for all containers. No, I'm wrong. They're just talking about other types of containers. Span, that's what I'm talking about. Okay, moving on. There's iterators, so all the various iterators in terms of getting through libraries. Ranges, which will fundamentally change how all that stuff I just showed you with all this, you know, begin, end crap. A lot of the querying side of these pretty much goes away and gets replaced with really cool, I mean, it doesn't completely go away, but it gets replaced with ranges, which are incredibly powerful. And that's part of my C++ 20 talk. Ranges are super cool. They let you do some really amazing things. There's numerics, so it's all that math stuff we just saw. Localization, I don't actually know anything about the localization library at all. But it's a way to allow for localization. I literally know nothing about this. I've never looked at this except to understand that there is something, but I don't know anything about this. So I'm not going to talk about this because I can't speak with any kind of authority whatsoever. I've never looked at it. If somebody does look at it or knows about localization stuff, like how C++ has made this change, I think this is implying that it's been around forever. I've just never used it. So it would be interesting to understand. Instead of polymorphic facets. Yeah, I have no idea what any of this is. In games, we have our own. So we're not using these libraries, which is why I've never used them. So it'd be interesting to see. Input output is like C out, C in, all that stuff. File system is like fstream. Oh no, file system is not fstream. Sorry, fstream is included in input output. So all the file manipulation, stuff like that. File system is like directory manipulation and stuff that was traditionally more very, operating system specific. They've done this in an agnostic way. So, navigating to different directories, seeing what files are there, that kind of stuff. Regular expressions. So a lot of people don't know that C++ 11 added regular expressions. I don't know anybody who's actually really using them for anything significant, but you're just not going to use them in games, really. They're just too slow. However, you might use them in tools. I am personally using them in tools. I have a C++ tool that I'm using, and I use standard regex in that tool. And it's a little clunky, as you would expect it to be, but it's fine. It's probably very slow, but I don't care because it's a tool. I probably spend more time watching the cout scroll than I do doing the regular expressions. Atomic operations. So atomic operation, so it's basically the standard atomic stuff. It's thread safety. So basically these two are the same, the thread support and the atomic expression, the atomic operations. These are all thread safe operations. So this is threading and all that kind of stuff, which is being able to take advantage of multiple cores. These are the major libraries that C++ 17, that C++ currently gives you. You can play with pretty much everything that's here, all the C++ up to and including 20 stuff. Some 23 stuff exists, but it's not in any kind of real state. I hope that that was useful as a bit of a tour. We did this in a reversed fashion, but I think it worked. My plan was to go through what I went through with like algorithms and stuff and do that first, and then ask if there's anything in particular that somebody wanted me to cover for the second half. And we ended up switching it because people had an interest in like optional variant in any. So I just reversed it. Hopefully that was a useful little tour. I don't expect you to memorize anything that I just said. What I do hope is that you'll go through what I just went through, and you'll be able to kind of
oh, wait, I think Rez said something. I thought there was maybe an algorithm for that, and go searching for it, right? That's how you're going to do this stuff. And I don't remember this. If I'm looking at your code and I know of an algorithm that would make something easier or more expressive, I usually mention it, and I might show it even in my feedback. There is rarely a correct answer in terms of should I use this algorithm or should I sort of roll my own. Except for like for each and a couple of other ones, I try to default more to the algorithm, like the standard library algorithm, but I'm not consistent. Maybe I should be, but I'm not. And it just depends. Sometimes it depends on how the mood strikes me, I guess. And so it's, I don't know that I have any really good advice for when and how you should use these. If it makes the code more readable to somebody who knows algorithms, because algorithms are going to look, they're going to look wonky for someone who doesn't really know them. But if it makes the code more expressive, simpler, I would probably use whichever one lets me make the code more simple. If I'm just writing a for loop that increments every value, I'm not going to probably make that an algorithm. And honestly, when I switch to C++ 20 and start using ranges, I will probably use algorithms way more, because at the very least, algorithms gets rid of the, I need a first and a last. So I'm always doing .begin, .end. Most of the time, you're going to do it across the entire range. Sometimes you won't, and you have this power still. But since most of the time you're going to do it across an entire container, it's way better to try and use sort of ranges and things like that. Okay, well, I should turn on the light. That's all I got. Let me know if you have any questions. I know that I didn't record much of this. I think hopefully I recorded most of the interesting stuff, but we'll see. And I'll post it when it's done. If I don't post it in the next couple of days, somebody remind me. The problem is that I do these on Tuesdays, and then I have my teaching day on Wednesday, and then it just flitters out of my head. I'm going to post the other two that I did. I'm going to hunt for those and see if I can post those up in the in Discord fairly soon. So those will be up pretty soon. We also internally just want to create a wiki so that this stuff can live there. Okay, that's it. Does anyone have any questions before we go? Any kind of burning questions? The one person who still has his camera on has shaken his head, so I'm going to take that as the ambassador for the entire group. Do you have what was I going to say? I don't remember what I was going to say. Oh, for most of the people who are still here have come to all of these, or at least most of them. So I think I have one more and then I'm done. Scott has some and Miles has some. So if there are, just be thinking about hey, is there something that you specifically want to know about? I feel like these have been relatively successful. I think they've been good. So if there's something that you guys want to know about, then let me know. And I think I want to start a thread or something at some point. What Scott? No, they're at. So the way that this works is everyone has office hours. My office hours are at this time, and so instead of taking random students asking random questions, I do this. And so my office hours will start. I don't know. I don't think I'm doing one next week. I think I'm doing one after that. I honestly don't remember. It's on my calendar, and my magical calendar tells me what I'm doing and when. But so yeah, my office hours basically will start. Yeah, where's my C++ one? I have no idea. It's not listed anywhere. Maybe I didn't add one for that. Oh well. I think I have one more, and I don't remember when it is.
I guess I closed Discord. This is actually bothering me, so let me open it up briefly. It should be here in the announcements. I kind of think we should move the sesh bot spam, the event bot spam, to like its own special place. Let's see, workshops, here we go. I should have one more. 20. Yes, I have one more. Oh no, I have a few more. I have two more. I have reading technical documentation. Oh yeah, that'll be fun. And then I have C++ 20 features. So see, reading technical documentation is like module 8, and then C++ 20 is like module 12. These are not on my calendar, so I'll add them. Anyway, if there's more that you want, the thing, if you go to the pinned items, there's a little pin at the top right. Oh, I'm not sharing anymore. That was not the share button. Okay. So this is Discord. Here's the programming announcements channel. It looks like this normally. If you go to this little pin, you'll see all the pinned things. And this top one here is the calendar of when they all are, which is really handy. So you can kind of see when are all the various like bonus lectures and things like that. And the second one is a spreadsheet that shows everything else, like at a glance, and kind of what they all are and the timings and all that kind of stuff. So this is an easier way to just kind of see who's doing what, sorted by instructor, it looks like. But anyway, if there's other things that you want me or somebody to go over, like in future semesters, let us know. We got exactly one suggestion this time. We did not get a lot of suggestions. Cool. All right, guys, that's all I got. Hit me up on Discord if you have anything else, and good luck. Wait, what does this say? This feels like it is part 1 and part 2 of C++ 20. No, most of the things I just went over were not C++ 20 specific. In fact, I mostly skipped over the C++ 20 stuff. A lot of what I got, well, a lot of what I went through this time is like C++ 17 and below. Ranges are C++ 20, concepts are C++ 20, modules are C++ 20, coroutines are C++ 20, and I barely went through any of those. So not so much. I mean, maybe if you think about it like that, it's like sort of C++ algorithms, I guess. My plan is to go through the core C++ 20 new features for that one. So concept, coroutines, and so on. I did a version of this in GAP 305, so I'm going to do that, but a little deeper probably. I haven't decided if I'm going to do coroutines. They're a real pain to go through. They're not, the idea and the bones are there, but they didn't add enough support for them, like standard library support for them. So they're a real pain to use. There's a like, write like 100 lines of boilerplate just to get something useful. All right. Cool, guys. I will hit me up on Discord if you have any further questions. But for now, I'm going to go and make some dinner. Bye, guys.